Hi, I'm Cassie, and I'm going to walk you through question 46 of the AAMC's official physics question pack that's going to prepare you for the MCAT. So this is still related to passage 7 about the student that takes some sort of object and propels it upwards. And we want to know for this question, how do we calculate an equation for the height of that object that the student propelled upwards? So let's break it down. Well, what principle could we apply here in terms of energy? So I've noticed with a lot of these MCAT questions about projectile motion, shooting things up into the air, you tend to have to use the principle of conservation of energy. Remember, conservation of energy is just the idea that no energy can be created or destroyed. In this case, that means what? When you take an object and you launch it up into the sky, initially that object has like no potential energy, because remember that gravitational potential energy, which is the type of potential energy that's going to apply here, is equal to mgh, the mass of the object times the gravitational force times the height the object is at. So when the object is on the floor, it hasn't been launched up yet, it has zero height, right? So that's why it doesn't have any potential energy before it's launched. But then as the object goes up, its potential energy is going to increase until it reaches its max height, we'll say here, and that's when it will also have its max potential energy. Now, what's going to happen in terms of kinetic energy when that object is projected upwards? Well, what's our equation again for kinetic energy? We said kinetic energy is equal to 1/2 the mass of the object times its velocity squared. So initially, when the object is launched, it has a lot of velocity. So this is going to be, when it's initially launched, is going to be its point of max kinetic energy. And then as it moves upwards and it is opposed by the force of gravity, that kinetic energy is going to decrease until this is its point of lowest kinetic energy, because it eventually reaches a point where velocity is 0, so then it won't have any kinetic energy. So this demonstrates how energy is conserved. As the object is launched and kinetic energy decreases, that energy just gets shuttled into potential energy, which is increasing. So no energy is destroyed, it's just converted from one form to another. So because of that, we know that this max kinetic energy value must be equal to this max potential energy value. So I'll write that as my kinetic energy max must be equal to my potential energy max. And now if we sub in our equations there, we know that our kinetic energy is going to be 1/2 mass times velocity squared, and our potential energy is going to be mgh. So then we can just go ahead and solve for our height here. So we get height is equal to 1/2 of mv squared divided by mg. So we notice something cancels, our mass, and then we get height is equal to 1/2 v squared divided by g, or v squared divided by 2g. And that corresponds to answer choice B for me. So the correct answer is going to be that our height is equal to v squared, our velocity squared, divided by 2 times our gravitational force. So again, this principle of conservation of energy, you're going to have to use flexibly in many different forms in the MCAT. So make sure you're comfortable with this question. I hope this helps. If it helps, give it a like. Feel free to drop questions and subscribe to my channel for more content like this.